Let's start with number 76, minimum window substring. So this is a hard problem, so let's focus on it a bit more. So in this we are given two strings s and t of lengths m and n respectively. We will have to return the minimum window substring of s such that every character in t including duplicates is included in the window, right? And if there is nothing like that, we return an empty string. So let's take this as an example and let's see how we are supposed to go forward with it. We'll have a frequency map for the t string, the smaller string, and it will have all the letters and their corresponding counts, and this will have the total counts for the number of alphabets we need to make a valid substring. Here is our minimum window that we'll use to keep check that which one is our minimum substring, and these are the letters we'll encounter. I've just kept them for reference here. To start with it, we'll move the R pointer. We get an A, so A becomes 0 and the count of alphabets that we need is 2, 1B and 1C. So we'll move R along, we get a B here, B becomes 0, that means we'll need one extra character which is C. And now when it comes to here, we get our C as well. The number of characters we need is 0 now. That means this is a valid substring which has all the required letters. So we can add it here. So let's also keep a count of all the elements we come across during our sliding windows. This is a valid substring. We'll now attempt to make the substring shorter by moving the left pointer. So we are losing an A, which means we'll be needing one A to make it a valid substring, right? A becomes 0 here as well. So we'll move the arc pointer again to look for an A which we need to make this a valid substring. And we encounter a B as well. We make it -1 because we have two B's, one extra B. We go to A. A becomes 0. Our count to look for becomes 0. This is another valid substring because it has all the letters we need. So we'll add this to our minimum window. We'll keep on checking which one is the minimum with each iteration. I'm just keeping everything to compare what are the strings we are getting. So since we got a valid substring, we'll try to shorten it. So we'll have to move the L forward. So O is not in there in our frequency map. B is there in our frequency map. But we can afford to lose one B because we have an extra, right? So we'll keep on moving. So here we'll lose a C, which makes it an invalid substring. In that process, this is what we are left with. Now, since we lost a C, the count is 1 for the number of alphabets we need. We'll have to move the R pointer to look for another C. So here we get a C and C becomes 0 now. So the count of alphabets we need becomes 0. So we encounter another N, we'll just keep it here. So this means this is also a valid string. But as of now, the minimum is this one. So now we'll try to make this substring shorter. So we can afford to lose a O, D, E. These are not even in the frequency map. And now we are here till B, A, N, C. So this is another valid string. And we'll try to make it shorter. And we lose a B again. So the number of B's we need to make it valid goes to 1. So now the R will go forward and look for another B. But it is out of bounds now, so the loop will stop. So I'll update it. So this is how our algorithm will work. This is just there for a better understanding. We don't need this. We just need to deal with the letters we have in our frequency map. We can get rid of this, and the minimum string that we can encounter is B, A, and C, which is also the answer for this question. So let's write some code. So first we'll create a map to keep the characters in T string and their counts. And now we'll have to move through each and every letter, and then we'll have a check. So if the map doesn't have the letter, we'll initialize with 1, and if the map already has the element, we'll increment the count by 1, and we'll create the count map. Great, we have built our frequency map for T string. So we'll initialize a few variable here. We'll initialize the left and the right pointer, and then we'll have a length variable. So length is set to infinity because any string that we encounter can be considered a minimum string if the initial length is kept to infinity. Because if we start it with some length equal to 0 or 1, any string that we encounter through the process won't be the lowest string we can find. And we'll have a count variable, which is the total count of our map, which we were doing here, which is the summation of these three. So it will be and a minimum window to keep the string that we find as the minimum string. So we'll start our while loop, moving the right pointer. We'll define the right letter, and we'll check if it is there inside the map. We set the count to whatever the count is -1. We'll add one additional check here. So if the count is equal to 0, the count will be reduced again. Then we increment the right pointer. Now we'll check for the count if it is equal to 0. Then we'll check for if the current window is lesser than the length, which is currently set to infinity. The length is now set to r minus l, and then we'll get the minimum window out of it, which is we'll define the left letter. So we'll check if the map has the left letter. So if the map has the left letter, we'll increment the count. So if the count of the left letter is greater than 0, we'll increment the count. We'll increment the left pointer, and then we'll return the min window variable at last. Let's try to run this. All test cases passed. Let's submit this.